Hello guys, here we have our this video for today is LU decomposition method. Here when we are talking about a defined matrix A, when we have a defined matrix A, we will try to solve it using our LU decomposition. Here I will try, this topic is very simple, a very simple topic in numerical analysis, but some students seems to find it difficult. So here I will talk a little, not that much in this method, although it's quite simple. I will try to do it in a way that you will understand it, also in a very simple and short way that you will understand it. This is this is our topic for today, LU decomposition, which we have. If you have a matrix A, should be equals to L multiplied by U. So this is all about it. A will be given to you. You will just to find your LU. So that is what we have for today. And our L, some students, they will try to do it in another way, that they will find A, L, so write L, then write U, which means after everything they will still fail it. The first thing you need to know when you are talking about LU decomposition method, the first thing you need to know is what L and U means. Now, what is L? Here, our L, let me use another pen. Here, our L here, what does it mean? It means lower triangular matrix. This is the meaning of L. And when we are talking about lower triangular matrix, when you have a matrix, when we are talking about lower, we are talking about this part. We are talking about this part, which means other values, other variable that is here will be 0. This is the values that we need when we are talking about lower triangular matrix. Similarly to U, what does it mean? This one means upper triangular matrix. So hereby, when we are talking about our upper triangular matrix, we have a matrix. When we are talking about upper triangular matrix, we are talking about this part. This part, which means other things here are 0. Okay, this is the first introduction of LU that you need to know. You just have to know that L is lower and U is upper triangular matrix. So when you're given a matrix A, and when you're given a matrix, try to make your values upper here 0, and try to make your values lower here 0. Okay, so this is just the introduction. Here, how do we know? In a normal function, we know that our Ax is equals to B, whereby Ax, okay, this is our function before Ax is equals to B. Okay, then when we say that our A from here, we say that our A here is equals to LU, which this A is LU. So what do we have? We have LUX is equals to B. This is correct when we're talking about LU decomposition method. This method now we're talking about. So when A is equals to LU, LUX is equals to B. Okay, then here u x, we always call it y. We always call it y. Okay, so u y is equals to b. This is also correct, and you just have to know these steps. This is the first equation. We turn it to lu x b, then take this as your y, this. So let me try to solve one example. This LU decomposition method is very easy, very simple, if only you understand how to do multiplication and addition of matrix. It is very easy for you. Let me try to solve one example based on this LU decomposition. It's not going to take us that much time, but we'll try to explain it. I will try to show you how we do addition and multiplication of matrix. Let me solve. Okay, our new paper. Now from here we will try to solve one example. Now let me say example 1, or let's just say example, because probably this is just one example that we are going to solve. Now our example, our A is defined. What is our matrix A? Say 2, 4, minus 6, 3. Sorry, let's call this 1, 1, 5, 3, 3, 2. This is our matrix A, and we know it's defined. Okay. Now the question we say express this matrix A. Okay, express this matrix A. Express it as A equals to LU. Okay, this is A equals to LU. You have A. Then we are trying to solve what is LU, which means LU, L times U will give us equals to A, this matrix. Okay, this is the example when it comes to LU decomposition. So what is the first thing you need to know is to, as I said earlier, the first thing you need to know is to know what LU means. Okay, then let's try to do our first step here. Our first step here is to express this. We will say that our A, let me use another pen. From here, A is equals to LU. Yes, that means our matrix A 2, 1, 1, 4. I'm trying to define the matrix A 5, 3 minus 6, 3, 2 is equals to our L. Come here. What is our L? Lower triangular matrix, which means we need only on those ones under, others are 0. So how do we define it? We will say here, let's call here L11, L21, L31. Okay, 0, 0, L2, 2, 0, L3, 2, L3, 3. Did you understand it? Here I told you that lower triangular matrix we need only those value under, others are 0. So this is exactly what we did here. We took those values under and make others 0. This is exactly what we did here. Similarly, we do the same thing in U. U, when we are talking about U, we are talking about upper triangular matrix, which means we need those values up, others will be 0. From here, okay, we say U 1, 1, U 1 2 and U 1 3. Okay, 0 U 2 2 U 2 3, 0 0 U 3 3. You see, here I have taken the upper triangular matrix and call these ones 0. This is the first step you will do when you're talking about LU decomposition. This is the first step you have to take. After you do this, now we know that this is our L and this is our U and this is equals to our A. Okay, now what is the second step? The second step is for you to take either this or this and call it this transpose. This is our transpose. When we are talking about matrix, a matrix, we call the straight line in the middle transpose. It's either you take your L and call the transpose 1 1 1 1 here, 1 here, or you come to L and take the transpose and call it 1 1 1. Don't take the two. Take either this or this. One of it, either your L or your U, and call it transpose. Okay. From here, let's take our U and call it our transpose. So what do we do? Now let's repeat our matrix A. From here, let me bring down matrix A. 4 minus 6 5 3 3 2 is equals to our matrix U. The same thing, we bring it down. L 1 1 0 0, L 2 1, L 2 2 0, L 3 1, L 3 2, L 3 3. Then this is the same thing, I brought it down. Then when you come to U, let me take this, the transpose as 1. So here we have 1 which is on top here, L 1 2 and U 1 2 and U 1 3. Then 0, this one again is 1, U 2 3. Then 0 0 1. You see, we've taken the transpose as 1 1 1. No more this, so that we can be able to find 1 2 3 4 5 6 7 8 9 equations. We will find these 9 values that when we multiply these two, it will give us this. Okay, now let's multiply. In matrix, you know how multiplications are being done. We multiply the top ones with these ones. Okay, multiply this with this, this with this, this and this. Then under one with this, the same with this, the same with this. Then the third one like this. So we go like this. Similarly like this and like this. Okay, then the second one we start again. This, then and the third one. This is how we do multiplication in matrix. So let's multiply. From here we will try to find what is L11, L21, L22. This L, we try to find it, and similarly to U2, U12, U13, and U21. We will find it. That is our main aim. Our main aim is to put these values, so that when you multiply this and this, it will give you this. Okay, so from here let's start. Our L11 multiplied by 1 times 1 here is equals to this 2. Okay, this times this is equals to this. Okay, so this is 2. And from here, let me use another pen. And from here, we know that L11 now is equals to 2. L11 now is equals to 2. This is equals to. Okay. Now here, L11 here should be 2. Okay. Then the second one is this. This times this plus this times this, which is 0, plus this times this, which is 0, is what we did. And we found this. Since this is 0, 0, 0, 0, we don't need it. We only need this times this. So the second one we have to do is this times this. L11 times U12. Okay? This times this plus this times this, which is 0, this times this, which is 0. So we only need this, which is equals to 4. This, we are in second column, and it's equals to 4. So from here, we will find our we found our LU to be 2. So from here, LU should be 2. 2 times this, which is 2 times U, this is equals to 4. So from here, also U12 is equals to 2. You see? Now we found our L11 and U12. What is our next multiplication? Is this one. So L11, let me try to do it here. L11 multiplied by this times U13, this one, plus this times this, which is 0, plus this times this, which is 0. So from here is minus 6. So from here, we know what is our U1. 2 times this is equals to minus 6. So from here, we have U13 is equals to minus 3. Okay, now we are finished with first column and first row. What is our next thing to do? We have to enter the second column. We have to enter the second column here. So from here, let me come over to this side. Okay, now from here, we've entered our second column and the second. See here, we multiply this. Let me just show you. When we multiply this times this, the same one we multiply this, and the same one we multiply this. Then when you come to second one, this one we multiply this one, multiply this one, multiply this, then this one multiply this, and this one multiply this. This times this plus this plus this. That is how we do multiplication in matrix. Okay, so you will keep doing the same thing because we don't have much time. I've shown you how to do multiplication. This up one will go down. Don't multiply up with up. We only multiply up with down. Okay, this column with row. So now we do the same thing here. This one multiply by this plus this plus this. Then this one multiply by this one, the same thing, and so on. So after you do your multiplication, I have done the multiplication. I did this 3, although I've solved it before. So our matrix A here, let me bring down our matrix A. Matrix A here is equals to 2, 4 minus 6, 1, 5, 3, 1, 3, 2. Okay, here we now have this here, which is equals to, as I said earlier, we are trying to find what is this L, what it is. So but from this little one that I've shown you, we found what is our L, we found what is this and this. We found what is it, and we say that is from here we say that our U1 L11 from here, L11 here is 200. Why? Because this is 200. Okay, now we also know that our U12, what is our U12 here, is 2. Then our U13 is -3. So from here, our U12 we said is 1, our U12 is 2, U13 is -3. This is the first multiplication that I have done. Try to do the rest. I've shown you how to do it. Just the multiplication is very easy. This row with this column, this row, this column. Then you enter the second one, this 1, 2, 3, and this 1, 2, 3. This is how to do the multiplication. So after you are done with it, you will find here 1, 3, 0, 1, 1, 3, 0, 1, 2, 0, 0, 1. I've done it before and I found these values. So you try to do it. We've done this one together. Try to do the rest and fix in the values. So this is how to solve for you LU decomposition. Just know that you will be given the matrix A, and you try to fix in this LU by writing them like this. Then try to choose any one of them, either L or U, to say that this one is 1, or you can take L and say this one is 1. Then you start to multiply. After you finish multiplying your values, you fixing them up here, fixing them up here. That is what we are trying to do, so that at the end you will find these values. Find these values. So this is all about LU decomposition. In the next video, we will try to solve another example, the same, using our another method. So thank you very much for this for watching this video. See you in the next video.